graphics.
Hey, that's when I start doing
It
mathematics.
involves solving algebra. Okay, so 3.2 is solving linear systems algebraically. Okay. Solving linear systems algebraically. So it says solve the system using the substitution method. I feel like this is out of order. Give me a second. I should have something prior to that. Maybe I don't have something prior. Okay, let's talk about something called substitution method real quick. Okay? A substitution method is what does that sound like when I say
You're
substitution?
substituting something.
Yes, so like in a sporting event, when you send a sub in, they literally take someone else off the field and then they become that person, right? Okay. Same thing happens when we're going to do substitution for math. What we're going to do is we're going to sub one equation in to the other equation. Okay? What that means is I have to get one of my equations into y or x equals form first, so that it will say x equals this, and then I can sub that whole equation into the x of the other equation and solve. Okay? So my suggestion to you is this. When you are using substitution, find whatever equation will come out to something easy. Like this equation right here, x plus 3y equals 3. If I solve it for x, I won't have any fractions. Okay? So if I say x equals negative 3 plus 3, that's easier to sub in than something with fractions. Yes? Okay? So what I'm going to do is I'm going to take this new equation, the way that I rearranged it, and I'm going to sub it in for that x right there. So you're going to get this. I'm going to make this equation green. So you're going to get 2. Thank you, Austin. So you're going to get 2 times, and instead of there being an x there, this whole equation goes there. 2 times 3y plus 3 plus 5y equals negative 5. Now, I only have one variable in my equation. Does that make sense? Oh, yes. It's negative 3. So I only have one equation in this whole, I only have one variable in this whole equation now. Okay? Does this take time? Yes. Does it take work? Yes. Is it hard? No. If you can do basic math like adding, subtracting, multiplying, dividing, you should be able to handle this. Okay? So what do I do to solve from here? What do you think I do next? Distribute property. So I get 2 times negative 3, which is negative 6y, and I get 2 times positive 3, which is positive 6, plus 5y equals negative 5. What do you do from there? Combine like terms. Okay, so I have a negative 6y and I have a 5y. What does that give me?
Negative y.
So I have negative y plus 6 equals negative 5. Now what? Subtract 6. Good. Subtract 6. Negative y equals negative 11. Now what?
Divide by negative.
Divide by negative 1, and y would equal 11. Now, that's not your solution, because your solution has to be an ordered pair. Okay, what am I missing from the ordered pair? An x. So what am I going to do with 11?
Oh my.
Plug back in. Now, here's the deal. You can literally plug it into this equation you've already rearranged so that it's easier, or you can plug it into either version of the other two. It doesn't matter which equation you plug it back into, you're going to get the same answer. So what I'm going to do is plug it into this equation, simply because it's already set up into x equals form, and it makes it easier on my life. So x equals negative 3 times 11 plus 3.
Negative.
Plus 3. What?
Isn't that
Is negative 3 the answer?
negative 30?
Oh, negative 30, yes. Sorry, I didn't hear you there. So then you get negative 33 plus 3, so x equals equals negative 30. When you go to write your answer, you're writing it in ordered pair form. So what is my answer in ordered pair form? Negative 30, 11. Yes, negative 30, 11. So when you give me an answer, this is your solution. And instead of graphing it, I solved it algebraically. Okay, because if I would have graphed it, they would have crossed at negative 30, 11. Do you see why sometimes I might want to solve it algebraically rather than graphically? What type of graph would this be? Would it be a large one? Do you want to sit there and graph that big of a thing? No. So using substitution might be easier for you. Okay, does that make sense? Can we comprehend substitution a little bit? Okay. Do you need more time to copy stuff down? Okay. And let's look at another method. Another method is called elimination. Now this personally is my favorite because it makes life so easy. Because when you're eliminating something, what are you doing? Getting rid of it. So I only have like one equation to work with. It's a beautiful thing. Okay? So in elimination, you're going to multiply one or both of the equations by a constant to obtain coefficients that differ only in sign for one of the variables. So if I have an equation that says 3x and another equation that says x, I'd multiply the bottom equation by negative 3 so that those would cancel out. Okay? We're going to do it together. I'm just giving you a little brief synopsis. Step 2 is you add the revised equations from step 1, combining like terms will eliminate one of the variables. You solve for the remaining variable. And step 3 is you have to substitute again. Okay? So it's multiply, add, substitute. It'll make more sense when we do it. It's easier said, or easier done than said in this case. We're going to switch that around. Okay? So elimination. The goal of that method is to eliminate one of the variables by adding equations. You will have to know how to do both because on your test, on your quiz, I'm going to specifically ask you how to do both. How do you do this one? How do you do that one? On your test, you will also, and in your homework, you also have options of like which one do you want to do. Okay, we're going to talk about when it would make sense to use one or over the other. Which option would make more sense? Okay. So we're going to solve this system by using the elimination method. So take a look at this equation, the two equations you have. You have 3x minus 7y equals 10, and you have 6x minus 8y equals 8. Are the x's or are the y's, any of them the same right now? No. Okay. What do I know? What do you think would be the easiest equation to multiply something by to get either the same x or the same y?
0.
Okay, no. You can't multiply by 0. Like, I need to either get this to say 6x and 6x, or this to say, 7 and 8, which isn't possible, so 56 and 56.
2.
Lily says, let's just do the 6x. And Lily would be correct because I would only have to multiply the top equation. I don't have to multiply both equations. Okay? So if I take this top equation and I want to change the x to 6, that means I have to multiply the whole equation by what? 2. When I multiply this whole equation by 2, I end up getting a new equation that says, actually, I want to multiply it by not 2. I want to multiply it by negative 2. Why do I want to multiply it by negative 2? So the 6x's will cancel because I want to eliminate. So if that is a positive 6x, which it is, I need that top one to say negative 6x. Does that make sense? Okay. So I want to multiply everything by negative 2. So what is negative 2 times 3x?
Negative 6x.
Negative 6x. And what is negative 2 times negative 7y? Positive 14y. And what is negative 2 times 10? Negative 20. That is my new equation that I'm going to work with. I'm going to take this equation here, okay, and I'm going to realign it so that it lines up underneath here like this perfectly, okay? And then I'm going to take this equation and I'm going to add them together. What happens when you get negative 6x and positive 6x added together? 0, which is what we wanted. We want those to cancel. What happens when you get positive 14 plus a negative 8y? Yes, so what does that come out to be?
6y.
6y. So I get 6y equals, and what's negative 20 plus 8? Negative 12. So what do I have to do from here, do you think? Divide by 6, good time. Divide by 6, and y comes out to be what? Negative 2. Now, that's not my answer. Why is that not my answer? I need an x. So what am I going to do with negative 2? Plug it back in. Does it matter what equation I plug it into? No. I can even plug it in to one of my, let's plug it into one of the original equations to make life easier, okay? So I'm going to just come, I'm going to just plug it into this part here, okay? So it's going to say 6x, okay, minus 8 times negative 2 equals 8. So I get 6x, what's negative 8 and negative 2 multiplied together?
16.
Not negative,
Oh,
positive. Okay, positive 16 equals 8. Now what do I do to solve from there? Subtract 16 and you get what? 6x equals negative 8. Then what do you have to do? Divide by 6 and x equals what? Negative 8 over 6, which reduces to negative, negative what?
4/3.
4/3. So now I have an x, whoops, and now I have a y. Now what do I have to do with that? Put it into a ordered pair. So I have negative 4/3, negative 2 as my solution. Okay? So elimination, I like if it works out easy. When you have equations where it's not as simple by just multiplying one of them and you have to multiply both of them and then eliminate, it gets more difficult. You will have a lot of work on your homework tonight. You will show me a lot of work, okay? If you don't show me a lot of work, probably not doing it right. We're gonna have, yeah, we'll have different stuff, okay? So then it says, to raise money for new football uniforms, your school sells silk screened t-shirts. Short sleeve t-shirts cost the school $5 each. Okay, short sleeve, $5. And are sold for 8. Cost is 5, they're sold for 8. Long sleeve t-shirts cost the school $7 each and are sold for 12 each. The school spends a total of $2,500 on t-shirts and sells all of them for $4,200. How many of the short sleeve t-shirts are sold? Ooh, what do you have to do here?
On the school.
You have to set up how many? 2. Yes, I need to set up 2 equations, Julie. So if I need to set up 2 equations, what would my equations look like? What would my equations look like? Okay. 5x plus 7y? Or what'd you say?
Yeah.
Is that what you said? Are you going with whatever I just said?
No, I think that's
Okay, so you want to say 5x plus 7y, okay? Here's why. You're buying both of these for $5 and $7, so I need to make that one equation, okay? So if I'm buying short sleeve for $5 and I'm buying long sleeve for $7, what is that total for the cost of both? $2,500, okay? Now, what is my second equation going to be based off of? How much they're sold for. So how much are the short sleeves sold for? $8. So that's going to be my 8x. Now, how much are the long sleeves sold for? 12. So that's my y. I have to make sure I line everything up. And what is the total that I made off of those? 4,200. Now, you can choose if you want to use elimination or substitution to solve this problem. What would be the benefits of using substitution?
What is that?
When I solve for like y and then sub it all back in. What would be the benefits of using elimination? If I do elimination, do I have to change both problems?
No.
Well, I can't get 12 and 7 to anything unless I multiply both of them, right, by something. And 5 and 8 would both have to be multiplied also, right?
Substitution.
So you want to try substitution?
Yes.
Okay, so which equation do you want to solve for, the black or the white? And do you want to, or black or the red? And do you want to solve for the x or the y? There we go, that's what I was trying to say.
Black X.
You want to solve for black x? Okay, if I solve for black x, I would get 8x equals negative 12y plus 4,200, and then I would divide by 8. What is that? So x would equal negative 4 goes into both of those. Negative 3 seconds y, right? Plus, what's 4,200 divided by 8? What's 42 divided by 8? What did you say? 525. Okay. So now I'm going to take this equation and I'm going to plug it in for the x over here. Okay. When I do that, you get 5 times negative 3 seconds y plus 525 plus 7y equals 2,500. Okay. What is 5 times negative 3 seconds y? Should be negative 15 seconds, right? That what it's gonna come out to be, negative 15 seconds. Whew. Negative 15 seconds y. What's 5 times 525? Plus 7y equals 2,500. So if I can combine like terms, I get 15, negative 15 seconds is negative 7.5. So I'm gonna get negative half y equals, and then I'm gonna do 2,500 minus 2625 equals negative 125. And to solve for y, I have to flip and multiply by negative 2 over 1. What grade? Okay, negative 2 over 1. So when I flip and multiply by negative 2 over 1, that means I multiply negative 125 by negative 2. And you get 250, okay? So I get positive 250. Now what do I do with that answer? Plug it into a y on the original. We don't have x. We have an equation for x. I know. So I'm going to plug it in to this y over here. So I'm going to say x equals negative 3 seconds times 250. It just takes time. It's not ugly. It just okay, what is negative 3 seconds times 250? So 250 times negative 3 divided by 2 is negative 375. So x equals negative 375 plus 525, which means x equals 150. So you are selling 150 short sleeve shirts, right? And 250 long sleeve shirts. That's how you would write your answer. 150 short sleeve, 250 long sleeve. Okay, that one's more complicated because you have to set up your own problem. one more example. How are we doing on that? You got that copied down? Okay, last one that we're gonna look at. It says, in general, the substitution method is convenient when one of the variables in a system of equation has a coefficient of 1 or negative 1. Okay, so this is how we can kind of tell which one's easier. As in the first example we did. If neither variable in a system has a coefficient of 1 or negative 1, it's usually easier to use elimination. Okay? So, on A, what do you want to use? Substitution or elimination?
Substitution.
Okay. Why substitution, Brady?
Because it has a 1.
Because x has a 1 in front of it. Okay? So if I solve this equation for x, it becomes x equals 2y plus 4. Okay? Because it has a 1, it makes it so much easier. There's no fractions involved. So I'm going to plug this in then. I'm going to substitute this equation in for that x right there. So I'm going to say 3 times 2y plus 4 minus 6y equals 8. Okay? What's 3 times 2y? 6y. What is 3 times 4? And what is this simplified?
Count the 6 Y's cancel.
They do, and then you would subtract 12 and you would get 0 equals negative 4. What's wrong with that? Does 0 equal negative 4? No, and I've eliminated y completely, correct? Okay, when you get a case where you eliminate a variable completely, okay, it doesn't even equal 0 and you get an answer that says 0 equals negative 4, 12 equals 14, something like that, okay? This is a special case. She's like, what? It's just simply called no solution.
Yes.
And you can stop right there. That's as far as you have to go. Brady's like, let all of them be no
Yes,
solution.
please.
Okay? So your answer to that is no solution. When that happens, there's nothing to plug back in, nothing else to do. It's simply no solution.
What if we would have done elimination? Would have been the same thing?
If you would have done elimination, it would have been the same thing because it would have eliminated a variable completely. Okay. What about over here? Elimination or substitution? What should we try?
Only the above.
That one's tricky.
What's elimination?
Those are huge.
Elimination's where you get the numbers so that they eliminate one of the variables, not both of them. Those are huge numbers, yes, I know.
I would do substitution.
I would do elimination because of fractions.
Well,
But here's what I would do. I know that, let me think about this. I know that you can multiply, like if I just did this, I know that you can multiply 4 by 7 to get 28, right? Least common multiple of something. So 4 times 7 is 28. And I know that 14 times 2 is also going to give me 28. The reason I'm going to eliminate those is because this one's already negative. So I can just redo my answer. So 7 times 4 is 28x minus 70y equals, is that 56? 8 times 7? 8 times 7 is okay. I'm just being stupid, that's all. And then down here, I would get negative 28x. And then 35 times 2 is 70,
what?
right?
Oh, Yoshi.
Oh, no solution.
You don't know that yet.
Negative 56.
And then negative 56. Okay? So what's going to happen is when I add all of these up together,
Get 0.
you get 0 equals.
0. Oh,
Oh, my goodness.
So it's not no solution, it's
One solution.
infinite
Infinitely
solutions. Infinite solutions.
Infinitely solutions.
Just blew my mind.
It's spelled infinite. I-N-F-I-N.
Just put it in infinite.
Make-
No, Derek, you are A.
Okay, so when the number, it doesn't have to just be 0 equals 0. If it said 12 equals 12, -6 equals -6, that's infinite solutions. When it comes out equal exactly to something, when both variables get eliminated, infinite solutions. When the answer comes out to not actually equal itself, or the variable is gone and it's not equaling itself, it's no solution. So that's what you're doing on your homework tonight.
You're so excited.